4.5c is graphing of cosines, and we are going to do both the graphing with phase shift and without phase shift today, positive and negative, so grouping all of it together today. In looking at our unit circle, because we're graphing the cosine functions, what we are looking at are the x values that are right here. And of course, we're only going to look at the important ones, or the easier ones rather. So we're going to look at the quadrantial angles. So these 5 right here. So this one, 1, 2, 3, 4, and back to 5. So pi over 2 pi, 3 pi over 2, and 2 pi right here. And when I do that, like I said, we're doing 0, pi over 2, pi, 3 pi over 2, and 2 pi. So when I start graphing these on my radian measure on my independent axis, I'm going to place those values just like we did when we did the sine. Nothing's different there. Where it becomes different is when we start graphing this. And now I'm going to go by 2 again. I think that's what I did last time. So -1 to +1 is what we're going to graph. And we have 0, 1. So we start now at the maximum. Before we started at the midline with the sine. But cosine starts at the maximum, the highest point, because remember, we can never go above or beyond this without any transformations. At pi over 2, I'm at 0, which is on the midline. At pi, I'm at -1. I'm at the minimum right here. 3 pi over 2, I'm back at the midline. And at 2 pi, I'm back to the maximum right here. And when you draw this, let me go ahead and do my second half over here where I have 2 complete cycles following the pattern. When you do this, you need to make sure at the end, when you come to that maximum, that you don't just put an arrow like that. That would be incorrect. You need to flip it down and turn the arrow down on both sides. So that's also the same with sine, but it's more common mistake on cosine because you sometimes, if there aren't any transformations, end at a maximum or a minimum and forget to curve it. So don't forget that. So here's how it's different. Before 1, 3, and 4, we're on the midline for a sine. But for a cosine, those are the maximums or the minimums. And when it is positive and when it is negative depends upon where you begin, rather, because you're starting at a maximum. So when it's positive, you start at the maximum. When it's negative, you start at the minimum. Points 1, 3, and 5, just like before, or the points that are on the midline, so 2 and 4, are always on the midline, regardless if you have a reflection or not. So when it's positive, you begin and end with the maximum. When it's negative, you begin and end with the minimum. And then you can see when the function increases or decreases first, but it's going to be pretty self-explanatory because you have to go the opposite way. Your domain and range are currently the same. Of course, that will change with transformations. So here's our first example of graphing a cosine. The first thing we need to do is find those 4 key features, like we have been with all of our problems, and look to see if you have anything in parentheses here that needs to be factored out. If you do, you have to start with that. We do not, though, so we have an amplitude of 2. Our b value is 3, so 2 pi divided by 3 is our period. Our phase shift, there is none, and midline is 1. So in creating our scale down on the bottom, we are going to go out to 2 pi over 3. And we are now going to divide that by 4, which we now know is the same as multiplying by the reciprocal. And what we get for that is pi over 6. This is 1 pi over 6. The next one is 2 pi over 6, which simplifies to pi over 3. 3 pi over 6 is pi over 2. And then 4 pi over 6 simplifies to that. And then our negatives. Nothing is different with cosine yet. And our midline is at 1. center of our graph. Amplitude is 2, so we have a maximum of 3. We have a minimum of -1, which is also our range. And we know the domain is still -infinity to infinity. Now, this is where it's different. We identify we are graphing a cosine graph. It is a positive cosine, and positive cosines begin at the maximum. So we are going to start at the maximum, we are going to end at the maximum, and the midline is halfway in between, which is, the minimum is halfway in between, and then points 2 and 4 are on the midline. And in going backwards, I can follow the pattern, or I could do what I just did on the other one. But you always start and end. Notice right here, I am beginning and I am ending in the same point in both directions. And now in just connecting these, I need to make sure I loop this around before I put the arrow so I do not cross either one of those lines. And this is my cosine function with the appropriate with the appropriate transformations. This right here is the exact same function except for it is negative. So I am going to draw or put all the information back on my last graph. You can just go over the top of your new graph. All right, so this is what your previous graphs look like. And again, you can just go over the top of this one. Now, the only difference between graphing a positive and a negative right here is your starting point. Instead of starting at the maximum, you start at the minimum. And the reason being is because all points are going to be reflected around your midline. Here's your midline. Instead of a maximum, it becomes a minimum. Every minimum becomes a maximum. And you can't reflect something around itself. It stays where it's at. So all these points on the midline are going to remain. So you would begin at the minimum. You would then end also at the minimum, end and begin at the same part. Halfway in between, you're at the maximum. So it would look like this. And likewise, following the pattern on the other side, it looks like this. Flip those tails up. So the green one would be my correct answer. And again, the only difference is when you're graphing a negative cosine, instead of starting at the maximum, you start at the minimum. Now I want you to pause the video and try this one on your own. It's very similar to the last one that we did, and then we'll get into problems with phase shifts. Now, really quick here, the most mistakes are made here from this scale. You need this scale down here, and I'll be checking those numbers to make sure that they're correct. So this was the math for that. And again, you're just counting by pi over 8. This was 1 pi over 8. This is 2 pi over 8 that's been reduced, 3 pi over 8, and 4 pi over 8 that's been reduced. And this is what your final graph should look like. You begin at the minimum because of the reflection right here. I have 2 more problems, both of them with phase shifts. So this one has a phase shift because there's something in the parentheses. That leading coefficient in front of the x has to be factored out. So we're going to factor the 2 out, divide this by 2, divide this by 2. This one you can see is pretty simple as far as the math goes. We get that. Our amplitude is 1. Our period is 2 pi divided by b, and the b is 2. So our period is pi. That one's easy to work with. Phase shift is right pi over 2. Remember, it's the opposite direction. And our midline is 3. Now, in creating the scale on the bottom, our period is pi. We will go out to pi. When you divide that by 4, clearly you get pi over 4. So this is 1 pi over 4, 2 pi over 4, which can be reduced, 3 pi over 4, and back to 4 pi over 4, which also can be reduced. And then put the negatives on the other side. Now, we have a midline of 3. So let's put that in right here. We have an amplitude of 1, so we will go up 1 and we will go down 1. And our function will fit in between those 2 lines. All right, so now because we have a phase shift, we have to begin right pi over 2. So here's pi over 2. This right here is going to be my beginning point. I'm going to start right here. And now, to determine where to start, we're going to look to see what kind of function we have. And we have a cosine function that is negative. Usually cosines begin at the maximum, but because it's been reflected, it's going to begin at the minimum. So we will have a minimum point here, and then the next point is going to be on the midline, that's point 2. The next point's at the maximum, and I could add more on the other side, but instead I'm just going to go the other way so I don't have to add more points, and I'll just continue to follow, making sure that I'm hitting every point in between. And if I do that, you will see I don't have to add any extra tick marks at the end. Curve the tail in both directions before you put the arrow, and that is my function. And the other thing that you should realize is if you take a look at starting at 0, this right here looks like a positive cosine graph. This positive cosine graph looks the same as a negative cosine that has a phase shift of pi over 2. So a lot of these functions end up looking like each other. Okay, one more, and this one does have a phase shift as well. We also have that leading coefficient we need to factor out. So when we divide this by 4, that's easy. Divide this by 4, it's already being divided by 2, so that's going to become a pi over 8. And we get this. Our amplitude is 2. Our period is 2 pi divided by b, which is 4, so pi over 2. Phase shift is, is right pi over 8, opposite direction. And the midline is 2. In creating my scale down here, my period is pi over 2, so that's going to be my end 1. And when I divide that by 4, or multiply by 1/4, I get pi over 8. This is 1 pi over 8, 2 pi over 8 that can be reduced, 3 pi over 8, and back to 4 pi over 8, which is pi over 2. And we'll get these negative values on here. And let's get our maximum and our minimum and midline. Our midline is 2 right here. We have an amplitude of 2, so we're going up 2 and down 2. Looks like we're going from 0 to 4 for our range. And now when I start graphing this, I'm going to first look at this phase shift. I'm starting right pi over 8. This right here is going to be my first, or my starting point. That is like my new y-axis. And then I have to determine what I'm graphing. So I have a negative cosine. Again, the cosine usually begins at the maximum, but because this is being reflected, we will begin at the minimum. We're going to begin at the minimum and end at the minimum. So I could put this last tick mark here and go like that, but I'm not going to. Instead, I know I have to go up here. It's the only direction I can go, okay? I can't go down because I'd be below the line. And then I'll get up to my maximum, and then back to the midline, and then I would go down there, but I'm going to do the same thing in the opposite direction. From this minimum, again, I have to go to the midline, have to go to the max, midline, minimum, midline. And then I can graph this. And if you take a look at this at the 0, so right here, one period of this, this actually looks right here like a negative sine graph. So this function I could write as a negative cosine with a phase shift, or I could write it as a negative sine graph without a phase shift, but with my amplitude, midline being, and period being the same. And hopefully that'll make sense to you. You can do your 4.5C worksheet. It's quite long because you have 10 problems and some have phase shifts and some don't have phase shifts. So make sure you're giving yourself plenty of time to get it completed and submit it into Schoology at the end of the day. And your test is coming up. So make sure you understand.